I would like to look at both of these blocks, block A and block B, and determine what the normal force for each of these blocks are. Now, if we look at block A first, block A occurs when this theta is equal to 0. It's directly below this vertical line. So in block A, theta is equal to 0, and if we draw our free body diagram of block A, all we have acting down is its mass, its weight, which is mass 0.6 times gravity, so 0.6 g, and we have a normal force acting upwards. And this is going to be n sub a. So this is going to be equal to a kinetic diagram where we say it has a mass times acceleration in the normal direction, so 0.6 times the acceleration in the normal direction, and because it's moving to the left, we're going to say it has an acceleration 0.6 times acceleration in a tangential direction. So let's sum our forces. If we sum our forces in our normal direction, we get a mass times our acceleration in the normal direction. We have this minus 0.6 g, and I should note that g is equal to 9.81 meters per second squared, which is gravity, plus the normal force of A is equal to 0.6 times the acceleration in the normal direction. Well, we know that the acceleration in the normal direction is equal to a velocity squared over rho. So if we substitute this in, we get minus 0.6 g plus na is equal to 0.6 times v squared over rho. And if we use this, velocity of A is 5 meters per second, and rho is this 3 meters, we get our normal force is equal to 10.89 newtons. Now, let's look at the sum of the forces in the tangential direction is equal to a mass times an acceleration in the tangential direction. However, if you look at this, you notice that there is no forces in the tangential direction. So our acceleration, our tangential acceleration, is equal to 0, and we only have a normal acceleration. So let's take a look at block B. And block B occurs when theta is equal to 30 degrees. So this is theta, and it's equal to 30 degrees, has a velocity of 4 meters per second. So let's draw the free body diagram of block B. And it's going to have a weight that comes straight down. This is its weight, so it's 0.6 times gravity. It's going to have a normal force. This normal force acts in this direction, and we'll call it the normal force of B. And these are the only two forces on it. Again, we're assuming a frictionless surface. So this is equal to a kinetic diagram. So right here. And we're going to assume it has a normal acceleration, so 0.6 times the acceleration in the normal direction. And we're going to assume it has a tangential acceleration, so 0.6 times the acceleration in the tangential direction. Now we need to do a little bit of geometry, and we need to figure out what this angle is right here. And since this normal direction is right like this, and this vertical direction is right down like that, we know that this angle right in here is 30 degrees. Just because this is a vertical line, and this 30 degrees is the angle that the normal acceleration is at, and what our normal direction is. So this is 30 degrees right here. So if we sum our forces in the normal direction, we're going to get NB and this is acting against the normal direction, so minus 0.6g times, and this would be our cosine of 30, is equal to a mass, which is 0.6, times the acceleration in the normal direction. Again, acceleration in the normal direction can be replaced by this equation, so we have NB is equal to 0.6g cosine of 30 plus 0.6 times the velocity squared, and our velocity of b is 4, so 4 squared over rho, our radius of curvature, which is 3. And we can solve for NB, which is our normal force, and we can get NB is equal to 8.3 newtons. Now, we can also sum our forces in the tangential direction. I guess I'll move it up here. And we're going to figure out what our tangential acceleration is. And this is going to be equal to 0.6g times the sine of 30 is equal to 0.6 times at. So both of these equations have a 0.6 in them, so they cancel out. And we have the acceleration, the tangential acceleration is equal to 4.9 meters per second squared. So what's the difference? Well, the difference is this block B has both a normal and a tangential acceleration, while block A only has a normal acceleration.